Okay, I think we're going to go ahead and get started. If you have a seat.
Yeah, it's in like in August.
Okay, I think we're going to go ahead and get started. So if everyone can have a seat, we would appreciate it. Hi, I'm Chris Lorenz, Professor of Biology at Thomas More College. And on behalf of the Marine Biology Lecture Series Committee, we'd like to welcome you. And thank you for coming out tonight to see Dr. O'Connell. On behalf of the committee, we would like to recognize Dr. O'Connell coming all the way from South Africa to be with us today. And I'd also like to recognize Greg Mackey, Dan Dunlap, Amy Wagner, Don Gorban, Allie Barber, and Julie Uffman from the committee that put this together and the rest of the lecture series. If we could recognize them with a quick round of applause. And on behalf of Thomas More College, I would like to introduce President Armstrong.
Dr. Lorenz is a little bit more athletic than me. That was a higher step than I thought. He played quarterback. I was a lineman, so that only makes sense. I'm Dave Armstrong, President of Thomas More College. I want to welcome you to the second Marine Biology and Conservation Lecture, a joint effort between Thomas More College and the Wave Foundation at the Newport Aquarium. And we address and promote critical issues in the fields of marine biology and conservation. Our inaugural event was September 9th with Dr. Guggenheim, the ocean doctor. And tonight we have another doctor. And I also want to add at that last event that our wonderful bartender Nancy out back was getting ready to leave for her honeymoon that night. So now she's back in the beautiful weather of Greater Cincinnati. So make sure you tell her we're glad to have her back. And I want to say Lindsay from Thomas More Admissions is back there. So any of you high school students, I'm going to put in our shameless plug. Make sure you get back there and get some information, and you can fill out an information card. We'd love to have you visit the college. Our partnership with Newport Aquarium and the Wave Foundation is actually a historic partnership. It's, as far as we know, Thomas More College's partnership with Newport Aquarium is one of the only one in the country like this. And we're very excited about that. So tonight it's about sharks. And I have to admit, when Dr. Lorenz told me that this was our second event, I was geeked up. I'm a Shark Week guy. I love it. And I have to tell just a little story on why that is. So I was 11 years old, and my family didn't have a lot. I grew up with there were 7 of us, 6 siblings. And so we always vacationed in Lake James, Indiana, which had bluegill and mosquitoes. If anybody's ever been there. You know, fun place, but. So my dad had a good year, and we went to Cocoa Beach with just 3 of us, my older brother Kevin, or 4 of us, and my sister Teresa and sister Mary. So I was 11 years old, and we go to Cocoa Beach, and I choose, we get into the condo, and they have a couple books on the shelf, and one of the books is Jaws. And I choose to read it. And I didn't sleep for 2 nighs. I thought that the shark was actually going to come out of the ocean, jump up onto the condo, and come and get me. You know, and I was 11, you know, so my dad, he was so upset with me, I wouldn't go in the water. It's like, you got to get in this water. I took this vacation, it cost a lot of money, get in the water. So finally, he convinces us, he goes and gets surfboards, and so me and my brother Kevin try to learn how to surf at Cocoa Beach. So the next day, he takes us, there's a big pier if you've ever been to Cocoa Beach. And there's this huge pier, so we go up there, we're gonna go fishing. And we walk up there and we rent the fishing rods and all that kind of stuff, and we get little minnows and all this kind of thing. And I walk over and there's this, actually he was kind of a younger guy, but very grizzled and, life had warmed down a little bit. And he stands there and all of a sudden he lays out this fish about this big out on the deck. And he pulls out this axe out of his bag and boom, boom, cuts it in 3. He takes this big gaff hook, puts it in one of the pieces, rolls it around his head, throws it over the pier. And I'm just thinking in my mind, what's he fishing for? We got these little hooks with these little minnows. He's got this big gaff hook with a half a fish. So I walk up to him and I'm like, sir, what are you fishing for? He looks at me in the old Quinn from the Jaws. I'm fishing sharks. He goes, I can't believe anybody swims in this area. There's sharks all over the place. So that was the moment that I learned that my dad doesn't always tell me the truth. Okay, one of those special moments as an 11-year-old. And I got a healthy respect for sharks. And so now, although that great fear of sharks has now turned into great respect and great wonder. And so I'm very excited to be here tonight to hear more about sharks and so how we can learn about sharks and our environment. So very excited. And with that, I would like to introduce one of the great people at the Wave Foundation, Dan Dunlop.
All right, good evening. Thanks for everybody that's showing up tonight. We really appreciate the support. This is only our second lecture series ever, but as you can see, can I see a show of hands? How many were here for the first one with Dr. Guggenheim? Fantastic. So not only do we have a number of people coming back, but we have a lot of new faces in the crowd too, which is excellent. So we really thank you from the bottom of our hearts. I also want to recognize everybody in attendance tonight that has helped the Wave Foundation. The 2015 year was a record year for us. We absolutely did things that we never would have dreamed of, and a lot of you are to thank for that. Your support, coming out to events like this, all the volunteers that are sitting in here, we truly appreciate that. We couldn't have done it without you. To promote the lecture series here, we ran a little competition to where we were going to offer a free penguin encounter if you actually registered by a certain date. Unfortunately, hardly any of you registered by that date. You would be amazed at the number of people, and you know who you are sitting down right now, that either walked up tonight or registered yesterday. So we were actually sweating bullets about a week ago, but like I said, everybody turned out tonight, which is great. So we did a little drawing here for a penguin encounter, and the winner is, absolutely going to butcher this, Emily Urichich. Emily, is this Emily? All right. Fantastic. Urichich.
One less chitch.
One less chitch. So anybody that wants to meet Emily or ask her to go to the penguin encounter, there's one less chitch in that. Urichich. Well, thank you, Emily. All right, and before I introduce our guest speaker, I want to have a shameless plug as well, and just say, for those of you that don't like the Wave Foundation on Facebook, please do. We're actually thinking tonight, maybe we won't let people touch the animals unless they like us on Facebook. But that's a great way for us to promote our activities, our events, things that we're doing in the community. So please, please, please like us on Facebook. And I just hit something I wasn't supposed to do. All right, without further ado, I'm going to introduce the one that everybody came to see, Dr. Craig O'Connell. So please come up here and take it away.
Thank you very much, everybody, for coming tonight. It's a real honor and a privilege to be speaking in front of you. I like to hear that story about obtaining a healthy respect for sharks. I had a moment like that in my lifetime, and luckily I had a camera with me to capture the moment where I got this whole newfound respect for these animals, and it's a ridiculous moment, and I'm going to show it to you tonight. So just got to wait for it, but it's pretty good. Now, I have to say I've been here for 2 days now, and I see a really unique program and a really unique opportunity for middle school students, high school students, college students. There's a really neat integration between Thomas More College, you have Newport Aquarium, and the Wave Foundation. And it's an opportunity like I've never seen before, and it gives these youth the opportunity to work with. I mean, yesterday I saw my first epaulet shark. Now here they are right here. You get to walk right up to them and see them, and you could even potentially conduct studies on them in Kentucky. This is an incredible experience, and I urge you to take advantage of it, each and every one of you. Before I jump into all the shark goodies, I just thought I'd thank the Wave Foundation. I got my PhD from the University of Massachusetts, Dartmouth, and following that I did my postdoctoral degree, and I finished that. I had a dream, and my dream was to start my own research program in New York. I knew there were sharks there, but I just didn't have the funds to start the program. But beyond that, I also wanted to bring this program into the New York City classrooms. I wanted to go out there and teach kids that don't necessarily have the opportunity to go out and see the ocean. I wanted to bring the ocean to them and teach them about it. And I was at this moment in my life where I was like, I don't know if I'm going to be able to make this happen. And then I saw the Wave Foundation. And I wrote a little proposal to the Wave Foundation. And you know, it takes a couple months to hear back from these things, but I was so anxious about it, but I'm pretty sure I wound up writing an email every week saying, did I get the grant? Eventually, sorry, but eventually I did, and it was something that changed my life, and it changed my whole career path, and it's something that made my dream become a reality, so I wanted to thank you guys for that. With that said, I am Dr. Craig O'Connell. I am the owner of a nonprofit organization known as OC's Conservation Foundation, and I'm a host for Discovery Channel Shark Week. And today I'm going to be presenting a lecture called Living with Sharks. I actually have an episode coming out this summer on this exact concept. And I thought what I'd first do is introduce you to my background. How did I get here? I'm going to talk a lot about my research. Now, I do a lot of youth education outreach, but today I'm going to strictly focus on my research and bring it to the concept known as the SHARKSAFE barrier. It's a new revolutionary technology that may potentially be implemented around the world to save sharks, hopefully, actually. And then I'm going to talk to you about the future directions of this barrier. And if some of you are getting tired towards the end of the lecture, I urge you to stay awake, because here at the end, something really, really neat. I was just in Bimini, Bahamas, and I was with a really famous cinematographer, and we teamed up, and he goes, Craig, you know, I built this little camera that we might be able to put on the top of the shark. Now, there's been similar things done in the past, but the cameras are huge, but he said, this one's little. And he goes, if we're able to attach this to a shark, we may get this whole new look at how the shark sees its environment, how it interacts with other sharks, and how it interacts with its prey. And so we decided to give it a shot. Now I have some of that footage. This is going to air on Shark Week, so you're going to be the first to see the footage. So stay awake for that. So how did I get started? I grew up having a passion for the ocean. As a kid, I watched Shark Week, and people would call and say, while Shark Week was on, oh, can I talk to Craig, blah, blah, blah. And I'd be like, Mom, no, I'm watching Shark Week. Tell him to call later. And so ever since then, I kind of knew that there's this passion inside me. It's something that I just always wanted to do as a kid. And now I'm studying sharks. I'm looking at sharks while I give a lecture. It's incredible. Come on. But anyway, this passion for sharks led to me doing my undergraduate degree at Boston University. And I can remember my very first class I took was ecology. I did very, very poorly on this test. It may have been the lowest grade in the class. And so I was really upset. And going to college from high school is a big transition. And I went to meet with the professor. I had a big conversation with him, and I said, listen, should I drop this course? I mean, am I going to fail this course? And he looked at me and he goes, Craig, you're doing well in your labs. He said, if you can turn your grades around, you should be able to pass. But then, right after that, he actually told me, and I'll never forget this, he looked at me and said, Craig, you're not going to have a future in science. And I kind of took a step back at that moment, and I was speechless. I looked at him and it's like, how can you say that to one of your students? I love marine science, that's what I want to do. And so the conversation pretty much ended there. And I said, thank you for your advice. And I went back to my dorm. And I thought about it. over and over and over again. And eventually I just said, whatever, that's his advice. I don't have to take it. And I wound up studying as hard as I possibly could, and I aced the rest of his tests. And I'm going to come back to that point at the very end of the lecture, because it's very important. It helped guide me in my career. Now, after that ecology class, I got the opportunity to work in Ecuador. And in Ecuador, it was a very exciting experience for me. I got to spend a month in the tropical rainforest, completely surrounded by nature. I did not have a cell phone, I did not have a computer. I was literally in the middle of the rainforest studying animals. Some mornings I would wake up and I'd hear, I had these really nice tin roofs, and you'd hear bang, 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 and you're like, what in the world is going on? It sounded like it was raining rocks. And I step outside, and there happened to be a troop of squirrel monkeys above my little house. And they're eating bean pods and then throwing them down on the top of the roof. So I went outside, of course, this is amazing, and I go underneath them and they start throwing the bean pods at me, and I thought I was playing catch with the monkeys, and then the bean pods changed into something else that monkeys like to throw. That's another story. But there was days where you woke up and the roofs aren't directly connected to the sides of the house, and I could remember one specific morning where I looked off to the side, right next to the bed, a foot from my face, and there was a tarantula just hanging out there the size of my hand. So it was a crazy experience, but one I'll treasure for the rest of my life. Now, beyond that, I got to go to Galapagos Islands, and I also got to spend some time at a local beach. And basically, this program encouraged students to do their own original scientific projects. And what I did is I went early one morning to this beach, and I noticed that there was an abundance of dead sharks on the beach. And so I spoke to the professor, and he said, Craig, you know, this isn't really that many sharks. You know, you realize this is the smallest fishing port in Ecuador. And so I said, well, how about I do a project here over the next 10 days and just quantify or count how many sharks they're bringing in and determining what types of species they're bringing in, just to get an idea of the potential impact that they're having here. He said, sure, that would be great. And this was a very open program. And what I mean by that is that he said, great, but you know, you got to kind of arrange how you're going to get there every day. And this is in the middle of Ecuador. And so one of the things that I looked forward to every morning was waking up at sunrise. And you basically, you hitchhike right outside your little hotel. And this bus comes and picks you up. And you have the opportunity to sit on the roof of that bus from the hotel to the beach, which is like a 30-minute ride. And there's something really strange that they do down there. I didn't really understand why they do it, but I would be up there in the morning watching the sunrise, and there'd be these bags up on top of me, and they'd start to move. And I started to look a little bit closer, and then they started to make noises, and there was pigs and bags, alive pigs, and so it was a really enjoyable bus ride from the hotel. Okay. So after I did this project for 10 days, I was able to determine that there's about 500 sharks that this really small fishing village brought onto the beach. And to me, that was shocking, this little fishing port, bringing in these sharks when they're actually targeting other fish. They're trying to catch swordfish, mahi-mahi, tuna. And so these are essentially bycatch for these fishermen. And so after that particular moment, I started to wonder, what could something like this do to the environment? How can removing sharks from the environment affect that environment? And so one of the things we know about sharks is that they're case selective, which means that they have slow growth, they mature at a late age, and they produce relatively few young. So if you take too many sharks out of the environment, it makes it really hard for their populations to recover. So I began researching this even further, and what I started to learn is if you have sharks, top of the food chain, and you have their prey. Let's just say, for the case of this, their prey is tuna. And the prey of the tuna is herring, and these herring are herbivores. They're feeding on, let's say, seaweeds or algae. Well, if you have continuous fishing pressure in an environment that's removing these sharks, what you begin to see is that the sharks disappear, and the prey of these sharks, they explode. So you have a bunch of tuna in the environment, and they completely eat their prey. And so there's not many of their prey left. And if you have less herring eating the seaweed, you have a huge algal bloom, and this could potentially and substantially affect the environment. So I began wondering, all right, if we're seeing this type of thing happen to the environment, is there anything we could potentially do to save it? So this was my senior year of college, and I was taking marine biology and physics at the same time. In physics, I was learning about this process called electromagnetic induction, where a magnetic field could eventually transition into an electric field, and I learned about sharks and how they have this really cool electrosensory system known as the ampullae of Lorenzini, giving them the ability to detect these electric fields. And so I was like, aha, now commercial fishing, recreational fishing, beach nets. Those are 3 sources of shark mortality, killing up to 273 million sharks. By the time I'm done reading this slide, that means that 190 sharks have died. By the end of this 1-hour lecture, 9,500 sharks would have been killed. And so it really motivated me to proceed with this idea. And so this is the actual drawing I made when I was a senior in college. And what I thought is, well, you could put magnets in the water, and since sharks can potentially detect these magnets, you can deter them away from these devices. And then I had the moment where I learned to respect these animals. Let's see, I don't know if it's going to play. It should play automatically. Let me set the stage, though. I got to test this idea in Bimini, Bahamas, which is a location that's about 50 miles east of Fort Lauderdale, Florida. And it's a really beautiful location where it's ideal to study sharks. So I went there and I developed this magnetic barrier. And I wanted to see how these juvenile sharks responded to the magnetic barrier, to see if the concept even made sense. So I got to the site, and it was nearing the end of my internship, and they had captured a 4-foot tiger shark. And I said, guys, this is the perfect opportunity for me to capture data on a tiger shark. Let me put the barrier in there and see how the tiger shark responds. Well, great. I got about 30 minutes of data, and the shark got a little bit stressed, and it laid on the bottom. I was young, and sometimes I make mistakes. And so I called into the lab and I said, guys, I know we have to release the shark this afternoon. I know you guys want to tag it, but is there any way, or do you have any suggestions how I can get this shark to move so I can get a little bit more data? And I don't know if it's going to work. They were working before, but if it does start working, this is the tiger shark. This is me wearing a jacket in the ocean. Let's just see if I can get it. They should play automatically. Yeah, it's loading. Got it? Now did it go? Oh no, it's not a good sign.
Yes, I'll be.
Okay, there we go. It said, poke it with a stick and get it to swim. Right. I had to mute the clip because I say a lot of stuff here, but. I caught it though at the end. Put it back here. Go watch it over and over again. There we go. Okay. So, yeah, that was a very integral moment in my life. I learned that I need to respect these animals. They're wild animals, and the second you get too comfortable around them is the second something like this happens. So I'm happy I learned this lesson. I'm happy I didn't get bit, of course. And this kind of changed my whole perspective on doing shark research. And now I'm very alert. Let's see. Okay, good. There we go. So it's working again. So now, let's see. Now I'm going to get into the background of my research. I talked about commercial and recreational fisheries, but there's another source of mortality, which is beach nets, and that's what I tend to focus my efforts on. Beach nets or anti-shark nets are utilized in areas such as Australia and South Africa. as a way to minimize the potential interactions between sharks and surfers and swimmers. Now these nets, as you can see here, are nets that don't go all the way down to the seafloor, and they don't completely enclose a beach. And what often happens is these sharks swim underneath the nets, hang out by the beach, swim back out towards the ocean, get entangled in the nets, and they perish. But in order to maximize the effectiveness of these nets, South Africa and Australia are now using baited drum lines, which are really large hooks, a lot of bait, and if they capture a shark that's over 3 meters or about 9 feet, they kill the animal. And the key reason for doing this is, of course, to protect their swimmers and surfers, but the real reason, if you speak to the governments, is so that there's less sharks in the water, which means that there's less potential for an attack, which means that more people are going to come to their beaches and spend money in their local economy. And so to me, it's a really sad approach. And one of the other things that's associated with these nets and these drum lines is that they're non-selective, so they capture and kill fish. So I have this motivation to find an alternative. But before I get to that, I'm just going to talk about 3 of these programs and discuss just some facts that I found interesting about it. The New South Wales program in southeastern Australia, I read an article very recently. And in this article that was published in 2009, the environmental minister stated that he was, he called this program a success. So I decided to look into the details of this successful program. And what I found out is that not all the beaches are netted in New South Wales. But along the New South Wales coastline, there's 38 shark attacks. Of those shark attacks, 24 of them, or 63% of these attacks occurred at the netted beaches. So I just found that kind of interesting that he's still calling that program a success. Maybe it would be a success if it was 20 or 30%, but 63%, I don't know if that's significant, but to me that's not impressive. Queensland, Australia, northeastern portion of Australia. Between 2001 and 2013, over 6,000 sharks were captured and killed within the nets. 3% of these sharks are not considered at a conservation risk. That means that 97% of these animals are on the International Union for the Conservation of Nature Red List, the IUCN Red List. What that means is that if there's any further exploitation of these animals, they could potentially become endangered if they're not already and go extinct. So with that, there's been a recent and huge opposition, both locally and internationally. And they're starting to look at some eco-friendly alternatives. But one of the things they don't tell you is they're using these new types of drum lines that they're considered smart. However, when you meet with the government and talk with them, they still say that if they capture a shark that's over 9 feet on these drum lines, they still kill it. So I'm not sure that's an eco-friendly technique. So most of my experiences with these beach net programs have been very shark-oriented. When you do a big conservation project and you're focusing on a species, you tend to have blinders on and only think about the species. You don't often take a really broad look at everything around you. But then I got to go to Reunion Island. Now this is an island located off the coast of Madagascar. And at Reunion Island, they have the highest attack rate per million people. If we compare it to the United States, the attack rate is 0.02, Brazil 0.02, South Africa 0.15, Australia 0.81, Reunion Island 8.28. Okay? So there's something really interesting going on there. Since 2011, there's been 18 attacks, 7 of them fatal. So everyone's really concerned. And when I went to this place, I got a whole new perspective on the situation. So this is for Shark Week. And I got off the plane and I didn't know what to expect. And thought, maybe I'd get to do some diving and investigate the waters. But there's a human element now. It's not just sharks. 5 minutes after getting into the car, they took me to one of their most famous beaches. And just out here was where there was a recent shark attack. I think this was the fatal attack number 6. This is when everyone has been fed up. They're trying to figure out, why the government hasn't done anything. And so what the locals are doing in response to this is showing major opposition to the government, saying, why aren't you doing this? Why aren't you doing anything to solve this issue? And so this is the entry sign for this most popular beach in Reunion Island. And you can see that there's this really graphic picture. And so the second I saw that, I said, you know, what am I getting myself into here? I was really nervous. Then we went straight to the town. And you're looking around town, there's graffiti all over the place. And I see this Ocean Interdit, and then who's next with the shark next to it? And I asked, this is the fixer who brings you around and shows you everything. And I asked her, what does that mean? And it means the ocean is forbidden. And then, of course, this is a very, very powerful statement right there. So again, I'm getting really nervous about this situation. But then the thing that had the biggest impact on me was this beach and this young boy. His name is Elio. He was a young surfer. He was between 11 and 12 years old. And I got to meet his family, have dinner with his family, and learn a bit about Elio. And just a few weeks before I'd gone there, he unfortunately got bitten by a bull shark. And this is the second day I was in Reunion Island, and they brought me to the site. And as soon as I got to the site, you can see on the road, they have his name painted in the road. And then they have, again, a lot of graffiti on the sign. Sharks area, they have a picture of a shark with a lot of blood. And I don't know what that means. Yes. It's never that easy. Okay. So, let me get back into the zone. Okay, so I got to this sign, saw this right here, and I didn't even want to go down to the beach because I didn't know what was waiting for me. But they said, you know, let's go down and you can check out the situation. And so I got down to the site. It's a really beautiful beach, really shallow water out here. It's about 2 feet. This is actually where the event happened. And you can see they painted his name on the rock, and it was a really emotional experience. And then I got to this. Now, with me and my research and my outreach initiatives, I believe that the youth basically hold the future of the oceans in their hands. And I think it's absolutely important that they learn the true beauty of the ocean and the true beauty of sharks. And once we can teach them that, they're going to want to protect them. And when I was in Reunion Island and I came across this painting, you could see a shark running away from a boy on a surfboard who has an axe. And I saw this, and it threw me aback. The film crew said, you know, Craig, can you talk about it? And I couldn't even talk because it really affected me, because it's illustrating the hatred that this community has in regards to sharks. So I got through that moment, and then I got down to the beach and I saw this. So this is a great white shark with a boy on it with an axe. And again, I don't know if you guys saw the episode, but I had to talk about this, and I had some weird accent came out of my mouth because I was so emotional about it. But it made me concerned for the island, not just the island, but the sharks and the whole community. So what that did is it put this whole beach net concept into perspective for me. It's no longer just the sharks, and there is a human side to it. Now, with that said, governments typically respond to these shark attack situations by quick knee-jerk reactions where, you know, they go out there and they say, okay, well, we're going to go out there and kill the shark that did this, which to me is nearly impossible to do, to find the animal that is often responsible for the attacks. Or they go out there and they say, we have to cull these animals and catch and kill as many animals as possible so it doesn't happen again. Now, when you go to an island like this, you can kind of see why they may respond that way. It's the entire local community is calling the government murderers. They're lining up outside the governmental offices and threatening them every day. So they feel like they have to do something. Now, to me, I think we do need to do something, and we have to do something quick. And so I think we need to do something that allows sharks and people to peacefully coexist along the coastline. And that's why I'm going to talk to you about my technology known as the SHARKSAFE barrier, which hopefully will do so in the near future. Now, I've tested this barrier system, which I'm going to talk about, in a variety of locations around the world. I've tested it on white sharks in South Africa and Guadalupe Island, Mexico. I've tested it on bull sharks. I don't know where the picture went, but I tested it on bull sharks in Costa Rica and bull sharks, great hammerheads, and tiger sharks in Bimini, Bahamas. So I'm going to kind of go over each one of those locations and what I did there. This barrier is based off of two hypotheses. The first being that kelp could be a shark deterrent, and secondly, that magnetism can be a shark deterrent. And the first one I'm going to talk to you about is kelp. So here is South Africa, my study site. This is called the Dyer Island Nature Reserve, right here. This is actually a bird sanctuary. Here is a very small island the size of about 3 football fields. It's known as Giza Rock, and there are 40,000 Cape fur seals on this island. And right through the middle is the hot spot. This is where, if you're watching Shark Week, you see the sharks breaching all the time. That's called Shark Alley, an amazing place. Now, if you look really closely at this picture, you'll see a bunch of dark matter. This is kelp beds. And when I first went to South Africa, I talked to some of the local fishermen. And they're like, we go spearfishing all the time in Shark Alley. It's amazing. We shoot these fish, we bring them into the kelp, and the white sharks come, but as soon as they reach the kelp beds, they don't come in. They don't follow us. We could bring the fish up to the boat, and yay, we're free. We escape the chomping jaws of a great white shark. And so I didn't quite believe them, and I looked into a lot of literature, and no one's ever studied to see if kelp actually is a deterrent. And you hear mixed reviews. Some people say, oh, we saw sharks in kelp. Some people say they don't swim into kelp. So I just posed a simple question. If I put these baited camera traps, which are made out of PVC, 5 pounds of bait, a GoPro camera, steel cable so the sharks can't eat it, deploying the hang to sing really simply, do these sharks actually swim in kelp? And so what I did is I deployed these camera traps in areas with a lot of kelp, in areas with moderate kelp, and areas with no kelp. And let's see if these videos work. So this is what it looks like in a high density kelp forest. Here's a pajama cat shark. These other fish are called hetties and bronze breams. And yeah, so you sit there for hours and you watch and see what shows up, which is a lot of fun. And then sometimes you take a sip of your soda, you look up, and then there's an octopus coming right at you. And you keep watching, hanging out, watching it a little more, writing your data down, creeping up to the camera. They're really curious animals. All of a sudden you take a sip and it disappears. When you look up again, and he's spying on you. Now this is the moderate kelp density, and you see a lot of stuff here. This is where you can see groups of Cape fur seals swimming together. That's one of their anti-predation mechanisms. They group themselves up and they're less likely to get attacked by a shark. And then you have these individual Cape fur seals that swim on their own, often wind up in the jaws of a great white shark. But they're curious, they're checking it out. They've never seen this before. And then you see a white shark show up. So right here, this answers the question, do white sharks swim in kelp forests? And indeed they do. But then it got really interesting to me because this white shark comes back in a second. And he eats the kelp. I don't know what that means. But anyways, here's some more pajama cat sharks. I thought this was a really nice scene. It's a really nice reef. You can see them investigating the bait, trying to get to it. But then, let's hope this video works. We're going to get to the no kelp area. All right, so this is the no kelp. And it's an incredibly exciting area. There's lots of sharks. Now the other areas you'll be watching the video and you won't see too much. You'll see the bronze breams, the hetties, and the occasional cat shark. But when you're here in the no kelp zone, you got to be watching the entire time because a white shark can show up at any moment. They could surprise you and come out of nowhere like that. What's really interesting to me is you picture these as being massive predators, which they obviously are, but they are quite delicate. And they come in, give a little gentle bite, and then they move on. Now that's a sign of their natural behavior. Think about us, we have hands. If we see something, we can investigate it like this, check it out. Shark can't do that. And so they come in and investigate with their mouth. There he eats a hagfish, pretty awesome. we'll watch it for another few seconds. There's so many sharks here, it's great. They're coming out of nowhere. There's one shark that I love. I don't know if you guys will find it impressive, but it's a 16-foot female that swims around really, really slowly. And you can tell she's been around for a while. She's pretty beat up, but I think she's coming soon. Maybe not this next one, but the one after. Yeah, it's the next one. I think. But yeah, so these hagfish sometimes get into the bait cage, and I bring the bait cage up, and they have this anti-predator defense they produce a ton of slime. And so when I first had one in the bait cage, the people on the boat knew all about them and I didn't. And so they're like, "Oh, Craig, you can take that one out." Good. And this is the shark I like. And I take this hagfish out, and literally I have like a half gallon of slime in my hand, so I got that thing overboard as fast as possible. No, I don't touch it anymore. But you can see this is a really big shark. It's moving around nice and slow. It knows it's the boss of this ecosystem, and it just swims off. So great videos. What does it all mean? Okay. After 160 hours of observation, I had to compile it and see if there's any trends. And one of the ways I looked at the data was the percentage of trials that I saw a white shark in. And if we look at the high kelp density, we saw sharks in 0% of the trials, which is interesting. Moderate kelp density, in about 25% of the trials, we saw white sharks. In areas where there was no white sharks, in about 82.6%, or actually exactly at 82.6% of the trials. So there's a clear trend there. But then I asked myself, well, you know, the thing that could possibly be happening is that you have the same individual coming to the same spots over and over again, so you're actually skewing your data because 82.6% looks great, but it's just the same white shark. It's not actually a composite of all the sharks in the area. So I decided to look at the data a little bit differently. And one of the things that's really interesting about identifying white sharks in particular, you could do this with other sharks as well, we're starting to do this with hammerheads, is you can look at the trailing edge of their dorsal fin, right here, and you can see a notch pattern right there. Now, each white shark so far that we've looked at has its own unique notch pattern, just like we have unique fingerprints, same thing with these white sharks. And what you could do is actually separate these fins into 3 different sections. Create a unique code for each individual animal. So if you ever see a white shark, you already have one of these ID codes, you can try and link it up and see if it's the same individual or a new individual. So we thought this would be a good way to see how many different individual sharks we saw in each different kelp density. So again, the high kelp density, we saw 0 sharks. The moderate kelp density, we saw 10 different sharks. And the area with no kelp, we saw 21 different sharks. So to me, we answered the question that sharks do swim in kelp, but we noticed that there's a trend. In the areas with high kelp density, you don't see sharks. And what this could suggest is that kelp is indeed a deterrent. So the second hypothesis I wanted to assess was whether or not magnetism, or second question, was whether or not magnetism was a deterrent. Now sharks, skates, and rays are unique, also known as the lazard rays, are unique because they have an electrosensory system known as the ampullae of Lanzini. If you look at this lemon shark, I've highlighted the ampullary pores, and they're located all over the snout, jaw, and top of the head of these animals. And these ampullae are used to detect the minute bioelectric fields from prey. So, you know, maybe, let's say a great hammerhead is trying to feed on a stingray. That stingray buries itself beneath the sand. Well, that stingray has a beating heart, and there's also a lot of muscle contraction. This is creating electric fields. These sharks have the special equipment to detect these electric fields, and they can still find them and still demolish them. Beyond electric fields, we suspect that these sharks can also detect the Earth's magnetic field. So if you think about 1,000 feet of water, there may not be a lot of geographical features that these sharks can key in on in order to see, you know, to navigate. But if you have these unique geomagnetic field lines going through the marine ecosystem, and these sharks can detect them, it's quite possible that they can utilize these geomagnetic field lines to navigate from point A to point B. So very similar to how we travel on a highway and use highway signs, these sharks may be using magnetic fields. Okay, there we go. Oh yeah, more videos. So using this concept that originated during my senior year of college, I was wondering if you have the Earth's magnetic field, which is really weak, it's about 0.25 to 0.65 Gauss being a unit of strength, and you present these sharks with permanent magnets, which have a strength of approximately 1,000 Gauss, which is orders of magnitude greater in strength than the Earth's magnetic field. Could you overwhelm the electrosensory system of these sharks and deter them? Now, the video's already stopped playing, but if you were watching, what you would have seen is as these sharks approach these magnets here, you get these really violent flinches away. This is one of my first tests on an adult tiger shark. And over here you would have seen bull sharks coming in to interact with bait that's attached to a magnet, and we were getting these very violent flinches away. Now, I worked on this concept for about 7 years. I did a variety of studies, and I had a lot of success. So what it told me is that magnets can also be a shark deterrent, which led to the development of this structure. This is known as the SHARKSAFE barrier. This is one unit of the SHARKSAFE barrier, and it's a simple structure. It's made out of ABS plumbing pipe or something similar to PVC pipe to create a kelp-like appearance. And then inside this artificial kelp, we place the magnets to create that additional deterrent effect. Now, we also have a buoy up here to make sure that the kelp goes all the way from the seafloor all the way up to the sea surface. And we also cut a joint in it to allow these artificial kelp to perform more like real kelp. And I'll show you some of that footage shortly. So the very first thing I needed to do was test out the concept. If I were to deploy this artificial kelp force and manipulate the swim patterns of white sharks. So this is a little, I'm using some scientific terms, but simply what I have here is an area without anything. It's called my control. I have an area with just artificial kelp, no magnets, and I have an area with artificial kelp and magnets. We positioned the boat up current from the barrier, and I chummed as much as I possibly could to try and get these sharks to swim through the barrier. Wanted to see if it's actually a plausible concept. Let's see if this one plays. I don't know if it's going to play. Let me come over here and see if I can get this one to go. Right. So what you're looking at, on occasion we have to go into the water and check out our barrier and do some maintenance. And so this is the first year that we did this project in Shark Alley. And what you'll see is a bunch of pipes in the water, and they're all bent. And the problem is when we started this project, we didn't have a lot of funding. And so I ordered a couple 100 meters of pipe, expecting them to come straight like you would order in a store. But they actually showed up in these rolls. And so I arrived in South Africa and I looked at these rolls of pipe and I would go, how in the world am I going to straighten these things out? And so we cut these rolls into sections, and then we tied each end to a car and straightened them out. And eventually they're somewhat straight, you know, a little curved, but now we use straight pipes and it looks much nicer. But what you can see is the pipes, and you see these little sections in the pipes. Those are the magnets. We're chumming through the barrier right now, also diving, not recommended doing that. But you'll see these sharks come in, and they see the barrier, and you get some really nice turns away, just like that. And so they see the barrier, they turn away, they see us, they get curious, and then they check you out. But you know, typically people depict these animals as being man-eaters, so you'd expect them to come up to you and bite you, but indeed they don't. They come in, they look at you with their beautiful midnight blue eyes, and then they swim off. Sometimes the situations get complicated and two white sharks show up, and then you just gotta hold on to that barrier and hope they don't see you. But you'll see they'll swim right along the barrier. They're absolutely beautiful animals. We did this experiment over the course of 2 years. We were able to identify 63 different white sharks that interacted with the barrier. And I'm just gonna show you or go over the results from one of the behaviors, the number of times the sharks swam through each region of the barrier, which are what I call the entrance behaviors. And we had 255 entrance behaviors through the region that there wasn't anything, which makes sense. And then we had 0 entrances through the areas that had the artificial kelp and the areas that had the magnetic kelp. So that's saying that it's working. I am manipulating their swim patterns. But I finished the study, and I began to think about this situation a little more. And I went through this whole situation yesterday. I got a tour of the aquarium, and I did a presentation. I came back here, and they're like, Craig, we're going to go to lunch. I said, okay. I walked out the door. There was a wall ahead of me, but I knew on the other side of that wall there was a beautiful cheeseburger that was waiting. And so what I did is I walked around the wall, simply, and then I ate the cheeseburger. And I said, oh, well, that's all I did with the white sharks. It's not that impressive. And so I took a step back and I thought about it after I finished the experiment. And then I realized when you do these conservation projects, you have to take baby steps. You start small and you work your way to the bigger concept. So we started small, we proved that the concept works, and then we moved to the next stage. The next stage is determining if this barrier could potentially be deployed along a coastline to effectively keep sharks away from people peacefully. So what I did, again in South Africa, is I deployed a exclusion barrier with bait in the middle, and because I had to deploy the bait, 15 pounds of tuna, I called this experiment the square of death. And so half of this barrier had magnets, half of this barrier had pipes with just no magnets. Yeah, so I started the experiment. Let's see if this video works. If I have to go and click it. No, it's working. Great. So it's really hard to see because of the El Nino situation. They had a very different winter down in South Africa. And the water was really murky and there was a bunch of different species. But if you weren't paying attention, 3 white sharks already swam by. And you're looking at the outside of the barrier. We did have GoPros attached to the bait can. And luckily we didn't see any sharks eating the bait in the middle. But this is what we had to do. We had to go through about 200 trying to identify individual sharks. We could see this one coming up along the edge. I think this is our best view, and I'll stop this video after this, but you can see this shark comes in. This is about a 14 to 15 foot great white, and you can see it kind of navigate around the barrier. So what we were able to determine from this past winter is that we had 7 different individual white sharks interact with the barrier, with 0 going through either sides of the square of death. And so what that's telling me is that there is potential that this could be an effective solution to beach nets. But 7 sharks isn't enough sharks, so we have to go back down there and collect more data. Now, the last experiment I will tell you about is a very similar study I conducted on bull sharks in Bimini, Bahamas. For this study, I had a region that contained no pipes, my control. I had a region that was a square, or a rectangle, I guess, made out of pipes that were just your artificial kelp. And then I had a region that contained the magnetic kelp pipes. And in each region, I put a bunch of bait, about 5 pounds in each section. And I wanted to see, well, you know, bull sharks are another species that poses a potential threat to swimmers and surfers. Could it work on them? But beyond that, I had access to what's known as an ARIS camera. It's a sonar camera. And what's really neat about this camera is it gives me the opportunity to conduct studies both day and night and clear or murky water. So even if I can't see the sharks, the camera can, and I can still collect data. Go. So, when I do my experiments, as you can tell, I'm obsessed with sharks. And so, as I'm deploying the barrier and it's not fully deployed, I like to put bait in the water and see what happens. And so this is just 1 row of pipes. The barrier is actually composed of 2 to 5 rows. But as I was deploying it, you can see that the bull sharks are coming in. There's a ton of bait inside, but they're not swimming through. So before we even got started with the actual experiment, I was really excited to see that, you know, this could potentially work. And then this one, let's see. Okay, I'm gonna have to try the trick again. So this is just some underwater footage, and after about 19 days of doing this, we started to see that there was a lot of reef species hanging out inside the barrier and around the pipes. It was almost as if they were using the structure as an artificial reef. And so you can see these barracudas, a really big predator. swimming through the pipes. And what was really neat about doing this experiment here is that I was able to actually see what was going on throughout the whole course of the experiment. And it was illustrating to me that this is shark specific in the sense that it really targets the ampullary system of the sharks, whereas the animals that don't have the ampullary system are swimming in and out of the pipes. So it's telling us that this is a good sign too. We're not just going to, we're only going to be excluding sharks, whereas the other animals can utilize these beach areas if it ever gets deployed at a beach. And so after 19 days of continuous chumming throughout this barrier structure, we had 1,260 entrances through the control region, which makes sense. There was nothing there, so they just happened to be swimming there. Boom, we knocked that down as a data point. But we had 0 entrances through the regions containing artificial kelp and 0 entrances through the region that contained the magnetic kelp. So this is really exciting for us. It's telling us that this indeed could be working. All right, so I'm not sure I'm going to be able to play this video, but if I kind of sum up what we've seen so far, and what we've learned is that the SHARKSAFE barrier is capable of excluding sharks through a variety of stimuli, not just visual where you have the artificial kelp, but the visual and magnetic as well. But I learned something else very interesting by using this ARIS camera at nighttime. Now, bull sharks feed on tarpon, which is this fish here. And this is the sonar camera, and it's really hard to tell what's going on in it. But if you look right along this region, you're going to see a bunch of little circles. And this camera creates an aerial view of the experiment. So it's like you're in a helicopter right now looking down on what's going on. And these little circles represent the tops of the pipes. Let's see if it works. Yes, there we go. So what you're going to see here, it's going to play again. It's too fast for me. Over in this area, you're going to see a bull shark. In a second. That's the bull shark. That's the tarpon. There's the tarpon right there. And what you're actually seeing is this bull shark trying to feed on the tarpon, and at the last second, the tarpon scurries away. And I remember watching this happen from the top of the dock, and I said, oh, this is it. The bull shark is going to swim right through the barrier. But as soon as the bull shark made contact with the barrier, it stopped dead in its tracks, did 180 degrees. So what that told me is that tactile stimulation as well could also be associated with the deterrent response, which was exciting. Now, whenever you develop these types of technologies, you wonder, okay, you have to see if it works, but you also have to make it cost effective, because if you want to implement a new technology, the governments aren't going to spend a ton more money for it, because if they have something that's cost effective, they'd rather use that. So I started asking the question of, why use magnets? Magnets just add cost to the system. And this leads me to the future directions. I did an experiment to help answer that question. What I wanted to do is see if sharks are more sensitive if they couldn't see. Okay? And the reason why I was looking at that is because in coastal environments where these beach nets are deployed, you often have really murky water. Sharks can't see there, so does that mean that they rely on other senses more? And to kind of support that concept, if you think about humans, if they can't see, if they're blind, some of their other senses become enhanced. They can smell better, taste better, hear better. And so I said, oh, great, well, why don't we actually test it out? Now, I know this is going to look a little invasive, but back in the day, in the 60s, the professor I worked with used a completely different technique where he took the eyes out of the shark in order to make them blind, and did his results, and then they eventually perished. And so we tried to make it a little bit better for the animals. And so what we did is we took 10 lemon sharks, and we took their eyelid, which is known as the nictitating membrane, and we sutured it closed. For 7 days, we let them swim around in the pen and acclimate. And I subjected 10 lemon sharks that are temporarily blinded and 10 sighted lemon sharks, 2 magnetic fields. And what we actually learned is the sharks that couldn't necessarily see too well, the temporarily blind individuals, were much more sensitive to magnetic fields. So to us, this was really exciting. Now let me just note that it's a really simple procedure to let these sharks see again. You cut the suture out, and in 3 days their eyes healed and they were back to normal. Well, what this told us is that in murky water environments, what happens is the visual component of the SHARKSAFE barrier essentially disappears. And that's when the magnets will become integral. These animals are no longer going to be using their visual system as much, and they may be keying in on their electrosensory system, thus making the magnets more effective. So we do need the magnets in these structures in the end of the day. So far we've had some very promising findings. We look to complete the exclusion component, the square of death, this summer. And then what we're hoping to do next is our first beach deployment to see if the concept is plausible, but not certain yet. So this is the last slide. And to all you youngsters out there, I would suggest there's you're going to go through times in school that are tough. But if you have a passion, never give up on it. And trying to do exactly what you want to do in life is never easy. If you think about this ecology professor, I could have listened to him and stopped science right then and there. I could have given up, which some people do, and that's fair. But if you believe in yourself and you believe in what you want to do and you have the skills to do it, then don't ever let anybody tell you otherwise. Go out there and do what you want to do, fulfill your dreams. And to everybody. Okay, so I wrote this before I got an iPhone. I used to have a flip phone, which is a week ago. And I couldn't understand why everyone was on their phones. I went to a concert and the guy came out, like the most exciting part of the concert, and everyone lifts up their phones. And they're watching the concert through their phones. And I'm like, man, you're missing the moment. But now I have an iPhone, so I use my phone all the time. But what I wanted to tell you is that it's important every once in a while to put your phones down, put your computers away, and go out there and live and explore nature, and learn as much as you can, because the more you learn about the planet, the more you're going to want to save it, and that's going to make the planet a much better place for the future. So with that, I would like to thank again the WAVE Foundation for giving me this opportunity, and each and every one of you for coming here tonight. It's an absolute privilege to be talking to you. And if you have any questions, ask away.
Greg, can you cue the video real quick? The teaser? Do we have that on here? All right, before we allow Dr. O'Connell to answer your questions, I'm sure you have plenty, and he's certainly willing to stay for that. We want to show you Dr. Lucy Hawks, who's our next presenter in May, a sea turtle expert, and she would like to say a few words to you guys, encouraging you to come back in May. And that's what we're going to do. And I would like to apologize for the ecology professor for doing that, especially myself. And I'd like the Thomas More faculty that's here, if you don't mind acknowledging your presence. If you could stand, my colleagues that came out from Thomas More. Go ahead and stand, please. Yeah.
All right.
We'll take this moment to actually have a surprise for Dr. O'Connell.
Yes. It's a good thing. He says, oh no. So join me up here. Get a little bit taller. I know you just spoke for the last hour, but thank you very much for being here. So Dr. O'Connell mentioned that in his very beginning that the WAVE Foundation did actually fund one of his projects a while ago. We've actually funded 3. And so we are actually very excited. I remember those emails where he was saying, like, I was emailing them, just asking them all the time. That was me. Yep. I definitely remember all those emails, and unfortunately, at the time, I was actually new to my position. I've been with the Newport Aquarium for 5 years, but I was new to WAVE at the time. It was actually when Dr. Lorenz was our chair of the board. So we're getting this proposal, and I'm on this committee, and this is one of my first committee meetings, and I'm trying to understand, and here's this proposal from a guy about sharks and magnets, and I have no idea what's going on, but it sounds awesome, and it's very exciting, and he seems so passionate about it, as you watch him speak, and yes, all those emails, but it's amazing just the people with the passion behind it. And so, a couple months ago, and I've actually been purposefully trying to avoid any emails from Dr. O'Connell for one reason, because he did submit another proposal for $6,000, and we have decided to fund that. So here we are. And he gets a t-shirt. say thank you for everything that you've done for us, even because I remember you guys should have been there for that meeting. We were talking about, who's this Dr. Craig O'Connell? What? But we actually, and we gave him everything that we had left for the year. He wrote the proposal in November. We're like, I think we have like $750 left for the year. And he got it. So he's come a long way. So thank you very much. You're wonderful. So, yeah. I was trying to avoid you. I didn't want him to ask. I really didn't. I stuck out. Sorry. All right. So, is the video ready now? Did we stall enough? There we go. Thank you. Oh, we're getting closer. You can see her, but you can't hear her. She has a wonderful accent.
I was like, that's a lie.
No, we can't do that.
Okay, good.
Oh my.
So the sound's not working correctly, so we'll encourage you to go back to the same site that you heard about this lecture and Dr. Guggenheim's lecture. Really take a moment. The video is excellent, gives you a prelude, a sneak preview of what she's talking about. She's a sea turtle expert, and she'll be back here with us today. So why don't you go ahead and open it up for questions?
Yeah.
So we're going to give a time for several questions and then leave a little time at the end if you want to come up and introduce yourself, particularly the students who are looking for some career advice and would like to meet Dr. O'Connell. We want to make some time for that. So, any questions?
Sure.
Dr. O'Connell, I was curious. You said you did this experiment with gray hammerheads as well, right?
Yes.
Did you notice that they yielded a more violent reaction to the magnets because their heads are like specialized to utilize the angular system better?
That's a very good question. What I've noticed is that bull sharks are the most sensitive. And one of the reasons I think that could be is that these bull sharks have very small eyes. And what that tells us is that their vision may not necessarily be as important to them as other shark species. And so they may rely more heavily on their electrosensory system to navigate and forage. So maybe that's why it's more effective on them. But we can't really say for certain. With great hammerheads, I'm actually finishing an experiment starting Friday. And we're going to deploy the exclusion zone in Bimini on them to see how they respond. But what we've noticed so far is that the visual component of the barrier is sufficient to manipulate their responses.
You want to go ahead and give us the mic on the podium, and you can use your lapel mic. We'll let the questions asked.
Sure. There we go. Okay. Can you hear me? Is that? Oh, that's good.
With your experiment on the kelp beds, did you notice a correlation between size of the shark and how often they went into the kelp? Like, did a smaller shark tend to enter more than larger sharks did?
So that's something we're also going to explore. And where we work, you typically have subadult to adult size white sharks. These are animals that are greater than 9 feet in length. And so our next phase of research would be to, still talking into the microphone. And so there's nursery grounds that we could potentially study this phenomenon, if you want to call it that. But the problem with those areas is that there are a lot of people that are also swimming in those waters, and so I don't know if we'll ever be permitted to do that. But if I had to take a guess, I think the juvenile white sharks would utilize the kelp force a bit more than the adults, but I don't know until I really test it.
Do the kelp and the magnets, do they have to go all the way to the top of the water, or would the sharks swim over them? And is there a limit to how tall you can make them, or they have to be potentially used in shallow water?
These artificial kelp systems have to go all the way up to the surface. If I leave a little gap, let's say, I don't know, 8 to 10 feet, the sharks will find that gap and swim through. So that's something that we have to make sure we have a continuous barrier going all around. And what you guys are seeing is just the bare bones of the system. you're seeing maybe 2 rows of pipes, and that's successful at manipulating their swim patterns. But if we actually implement this system, let's say in South Africa and Australia, it's going to be something where you have about 5 or 6 rows of pipes. That's still in a cost-effective strategy, but you're adding that extra, I guess, safety by having more pipes, a bigger visual system. The other thing, and to answer your other question about water depth, we've deployed it in about 40 feet of water. And it's worked okay, but I don't know if I'd go much further than that. I don't know why, but I wouldn't. But it works very well along the coastline, and that's our overall goal. I did come up with a new application for the technology, so it would allow us to deploy it in deeper water systems. But we have a portable bottom so that we can make the seafloor much higher. And we test this for Shark Week, so you'll see it this summer. And we tested the barrier in 300 feet of water, created this floating barrier system. I went inside of it while they were chumming, and these white sharks were coming all around, and they never swam through, thank God. Yeah, so we're still working out the logistics of it, but shallow water is better.
Thanks, Doc. I found your results of your analysis pretty remarkable. I like to display your data using GIS, but on a side note, the question I had is your SHARKSAFE barrier, you mentioned the magnets in ABS plastic.
Yeah.
Is there any cause for concern, the impact of using ABS plastic, especially, you know, if it was a global solution?
There's issues with using plastic in the ecosystem, and there's also issues with the structure actually floating away to somewhere and landing on, let's say, where we use the structure, there's a bunch of penguin nesting sites. And if that barrier comes loose, that could potentially be catastrophic to those penguin habitats. And so what we're doing right now is creating an effective structure so that these pipes don't break loose. And we're working with engineers so that if you have heavy wave activity, these pipes aren't going to break. That's the problem with a lot of these technologies right now, is that these technologies can't withstand heavy wave activity. Every time you have a lot of waves, they go into shore. And that's why our structure is much different, is because we created a joint. When I first, actually it's a good story. When I first developed this barrier, I had these 20-foot long pipes that I put into the water. And we spent about 5 days deploying them, and it was extremely exhausting, and I didn't want to swim with white sharks, but I had to in order to deploy this barrier, so it was scary. On the 6th day, we go out there to start running trials, and the barrier's gone. And I looked at everyone, and I was like, oh no. It's like, we can't start all over again. And then I was like, well, where did these things even go? Then we looked down on the sea floor, and these pipes were all laying against the sea floor. So we all were left scratching our heads like, what do we do now? I mean, there's a ton of buoyancy in this, but there's a lot of current in Shark Alley. And then we took a look and started watching kelp and how it performed in the ocean. And what we noticed is that it's very flexible. It's not one rigid pipe. It moves like this. And so we took all the pipes out of the water, which took another 3 days. Then we brought all the pipes onto land. We cut these pipes, we cut a joint towards the bottom. We call it a forced displacement joint. So now if the current comes, originally you'd have the current coming and pushing the pipe down. Now you have this forced displacement joint right here. The current comes and it bends the pipe like this. But this joint actually absorbs all that wave energy, all that current. So then you still have this continuous barrier from the seafloor to the sea surface. And so that was one of the modifications we made that makes it much, increases its structural integrity, so we don't lose the pipes.
Is there any danger in the magnets interfering with the shark's ability to seek out their prey, or is it just simply deterrent?
It's so the way we look at this, the magnetic field extending from those magnets is about 30 centimeters, about a foot. And so it's not an effective range where we're covering, you know, let's say 30 feet or 100 feet with these magnets. It's a very small range, and we look at it as it's positive for the species because we're only going to be deploying these in areas where beach nets exist. And so rather than killing the animals, we're providing an alternative that's much safer, and they can still utilize the areas outside the forage.
Do you have to replace the pipes, and like how often would you have to replace them since they are plastic?
That's a great question. We've left them deployed so far for 2 years. in Shark Alley. And what's really neat is I should have showed it to you guys today. I just got a video of the structure, what it looks like. And when you leave things in the water for a really long time, that you tend to get biofouling, things growing on it. And what the major concern was originally is that you'd have so much stuff growing on these pipes that it was going to weigh them down and they were going to be on the seafloor and be completely ineffective, and it would have been a disaster. But what we've noticed so far is that they're actually beginning to look more and more like kelp, because on the base of the structure, you're starting to see the kelp growing around the system, and on the pipes you're getting this nice film, and you're getting strands of kelp growing off of it. So it's actually looking like a natural kelp forest. So far, so good. They've lasted 2 years. Maybe in other ecosystems you're going to get different things growing on them and it's going to weigh them down, but we haven't gotten there yet. We're taking our baby steps to get to that eventual point, but good question.
At the beginning of the lecture, you mentioned that they used to use nets to catch the sharks. They'd also catch things like dolphins and sea turtles in them. So if these magnets do work as a barrier, would that have any effect on keeping them safe as well?
That's great. Good. Okay. So we can't really say that it's not going to affect the whales or anything like that until we test it. We've gotten a lot of data on Cape fur seals. And what we do notice is that these animals are swimming in and around the pipe, similar to how they behave in the kelp forest. They can utilize these dense kelp beds as an anti-predation mechanism to get away from the great whites. And what we're seeing is that they're utilizing our barrier in a similar fashion. They hang out in the pipes, they play around, and it's really neat. In terms of dolphins and whales, what I can say is that if a whale were to see the barrier, maybe it could manipulate their swim pattern. It's not going to entangle the whale. But if they wanted to swim through the barrier, they easily could. We drive boats through it all the time, and the pipes just simply move down. And we could swim through it just fine. So I could see maybe dolphins can easily navigate their way through it. A whale, I don't think it can navigate its way through the barrier, but it can definitely swim through it. So no source of entanglement. Yes, so that's a great question. So we initially started the project putting magnets in every single pipe, and that was just getting to be too costly. And the other thing we started to notice is after time the pipes are moving like this. If you have too many magnets in the pipes, and the pipes come together, then the pipes stick together. And so you don't have a barrier at all, you have a tangled mess. So what we realized is that you can have the structure, and you can have the outer row just have magnets, and all the inner rows, maybe 2 rows, maybe 4 rows, without any magnets. And what that does is it creates a big visual barrier, but as the shark comes up to it, they get that initial dose of magnetism, which is sufficient to deter them. And so that was one way that we minimized the amount of magnets in the system. And the other way was that we rigorously studied how far these magnets could be away so that we can at least get some sort of field extending away from them. And so we've minimized the quantity of magnets by maximizing their spacing while still being effective.
Okay, we have one last question.
But wouldn't eventually there be too many fish caught in like the inner part of it, so the shark population could potentially go down?
In the sense that that they can't swim out of it, you mean? Yeah. So what we see, that's a good question, is that these fish are swimming in and out of it all the time, continuously. So maybe some of them go in there and hang out, but then they swim back out to go on and do what they're doing. So far we haven't seen any effects like that, but we're definitely going to study it to make sure that we're not, doing something harmful to the environment that we didn't see. And that's important with science. It's great to create technology, but if that technology is detrimental to the environment, then there's no point. So, see, getting there.
Okay, we had 2 hands up at the same time, so we'll wait.
Okay, last question here, and then we'll let everybody disperse. And if anybody wants to come up and meet Dr. O'Connell, feel free to stay around. So, last question here.
What species did you think was going to be like most problematic or difficult in deterring away with the magnets or the kelp?
I'd have to say, I think bull sharks. And my rationale for that is, I knew the magnets worked, but if you think about white sharks, they utilize areas that is often associated with kelp. Bull sharks don't. They live in warm tropical waters where kelp doesn't grow. And so I figured the concept wouldn't work at all because, I mean, they could just swim through, find gaps in the magnetic fields. But luckily, they're also, they see those pipes and they stay away. But they bump into them a lot more than other shark species. But like I showed you, they bump in and they swim off. So it still works.
All right, let's thank Once again, be safe on your way home, and we hope to see you in May.